So today's video about MySQL is all about using inner join to connect multiple tables. If you're doing a select statement and you're trying to retrieve data from a database and you want to get data that comes from different tables, but you want to combine it in one single record set, inner join is the way to do that. So let's talk about that. I have a SQL file here. If you've been following along with this series, then you've already got all the data. If not, or if you want to start from fresh, this is the SQL file that will create the three tables, movies, genres, and people that I've been using and will use in this example. So you can feel free to download that, expand the zip, and then inside of phpMyAdmin, go to your database, click on the Import tab, choose File, choose the SQL file that you just downloaded, and click Go. That will create for us the three tables, genres, movies, people, and put all the data inside of there. So let's go into the movies table and take a look at that. Inside of here, we've got 5 columns. Movie ID, which is the primary key, that's the unique value for each row. Title, director, year, pretty straightforward. And genre ID, this is the number for the type of movie it is, for the genre of movie. If we look inside of the genres table, oops, wrong one, back up to movies, browse the genres, you can see these numbers refer to actual labels. So what I want to do is I want to get a result, a record set that's going to give me director, movie title, and year out of the movies table, and then also the genre title from this table. So I want to combine those things in one single record set. Now, this is a relational database that we're building. MySQL is a relational database. So the relationship between these two tables is that there is a column called genre ID, and the numbers in here, these primary key values, refer to the numbers that are listed in here. We can't have a number in here if it's not showing up in this table. So that's the connection between the two of them. That's the relationship between these tables. So let's jump into the movies, and we will just use that as the place where we're going to run our queries, because this is where most of our data is. Now I could do it from either tab. I'm just going into movies to browse the results. So basic SQL statement, a select statement inside of our SQL tab, select star from the table where, and this is where your filter goes. So we're going to be retrieving the movie title, the director, and the year, those 3 columns from the movies table. The genres table is going to have a field called genre title. Now the backtick characters are there because it automatically throws them in. We don't need them. I could remove them from here, it wouldn't cause a problem. In my from clause, here I need to list all of the different tables that are involved. So movies and genres. Now a good practice here is to give these aliases. That was covered in a previous video in the series. So I'm going to give them the nicknames M and G, just because it's quick and easy to type. Now the movie title, this is going to be from the movie table. Now one important thing to note is if you have a column whose name only exists in one of the tables, you do not have to give it the alias. You do not have to put the letter M or the word movies in front of each of these. Because it's unique, MySQL looks at it and says, okay, well, there's only one of the 2 tables that actually has a movie title in it, so I know which one you're talking about. The problem happens is when you refer to something like genre ID, it exists in both tables, so you do have to be specific for that. If I was retrieving genre ID, I would have to say where it's coming from. Okay, so if I retrieve just this, I want to get the movie title, director, year, genre title from these 2 tables. So I'm going to run that query. With this query run, we're getting here 224 total rows. So why are we getting so many rows? We only had we had less than 30 movies. We only had 8 or 9 genres. So how do we get that many? Well, it happens because you can see here, for the movie Labyrinth, I'm getting every possible genre. For the movie Highlander, I'm getting every possible genre. For Alien, again. So for every single one of the movies, we're getting every possible genre. We haven't explained to MySQL how the two tables are connected in this query. So in my select statement, I have to define how I want to connect those two tables. Now, we could do this. Now, this is a bad practice, but I'm going to show you because it does work. Oh, this result is called the square product. Basically, it is you take all the records in one table, multiply them by all the records in the other, and that's how many records you're going to get back. I only got 224 with that small number of movies that we got. But if you had, say, 1,000 movies times 10 genres, that's going to give you 10,000 records. If you had 10,000 movies, which is very reasonable for a movie database. If you had 10,000 movies times 10 genres, that's 100,000 rows returned. So you can see as the number of records in each table grows, you are going to get a lot more results. If you had 1,000 records in one table, 1,000 records in the second, and you didn't say how they were connected, that's going to be 1,000,000 records that you get back. So very important to define in your query how the tables are connected. So we can say here where movie.genreid equals genre.genreid. That is going to filter it. Like I said, this is a bad practice, but it does work. If I run it, so we are defining what to filter. I do get the proper set. Now for each one of them, I am getting the proper result. The problem was that in my result, what I did was I got that square product. I got that huge record set. And then I told MySQL to go about filtering it. So it retrieved all the records and then it went through and just pulled out the ones that matched. If you've got a huge record set, that's going to be very poor performance. So instead of doing this, the where clause is supposed to be get the minimum number of records and then filter those. So I'm going to remove this where clause. I don't want that where clause in here. What I'm going to do is use the keyword inner join. So I'm going to tell it, when you go to retrieve the records, only get the ones that match between these two tables. So we have to now define, okay, fine, it'll do that, but what is the connection? On, this is the keyword. Instead of where, we're using on. And we'll say movie.genreid equals genre.genreid. Now that is the better performing way to do it. So we're selecting those 4 columns from the 2 different tables. We're saying inner join means basically where the 2 record sets overlap. You can picture it as a Venn diagram, those 2 circles that overlap. We just want the part in the middle. That's going to be the record set that we really want. Where the 2 circles of data overlap, that's what an inner join is. So genre ID, okay, go. And once again, we got the proper record set. We got everything that we wanted. All the proper records came in. So this is how we are supposed to do it. Now, if I want to filter this additionally, we can say, okay, where everything connected, that's the overlap, that's the inner join. Now, let's say, get me all the movies that were before the year 2000. Now I would use the where clause to say, where year less than 2000. That's a proper use of a filter. Go. And there we are. So here's all of our records, the movies with the proper genre category listed. So the full string, and we've filtered the records. We can also add in the sorting if we want. So order by year ascending. There we are. From 1977 up to 1999. All right. So if you have any questions, please feel free to leave those in the comments down below. I will leave a link in the description to the SQL file so that you can download that if you want it. And as always, thanks for watching.